Hello everyone, my name is Ainembabazi Britah and I'm going to discuss about machine learning and then its application in the real life. So, machine learning is basically the field of study that gives computers the ability to learn without being explicitly programmed. For example, instead of writing specific rules for every situation, we allow the system to learn from historical data and make predictions of the new data. Then we have two types of machine learning, one being supervised machine learning that deals with labeled data, and unsupervised machine learning that deals with unsupervised data. Then we go to models in machine learning. A model is a representation of some phenomenon, and we basically have two types of models. One is deterministic models that doesn't deal with randomness, then probabilistic models that deals with randomness. Then next we go to linear regression. Linear regression is a supervised learning algorithm used to predict continuous variables. Linear regression, it assumes the relationship between the independent variables and the dependent variables to make the prediction of anything that you want to predict. Then we go to logistic regression. For it is used for binary classification on problems. Unlike in linear regression, for it predicts probability between 0 and 1 using the sigmoid function, as you can see it from the diagram. Then we go to KNN, which is K nearest neighbors. KNN, for it is a non-parametric supervised learning used for classification and regression. Then we talk about how it works, as you can see from the diagram. First of all, we calculate the distance between all the training data and the test point. After getting that distance, we find the nearest k neighbors by sorting those pairwise distances. Then we classify the point based on a majority vote. Then we also have the applications of KNN. One is text mining, then we have agriculture, we have finance, and then cargo competitions. Then next we go to Gini impurity and entropy. Let's first talk about Gini impurity. With Gini impurity, it measures how often a randomly chosen element would be incorrectly classified, and its interval is between 0 and 0.5. Then its formula is there. For it is less complex because it doesn't use logs, and though it is too fast compared to entropy. Then next we talk about entropy. For it measures the level of uncertainty or disorder, and it ranges from 0 up to 1. For it, when you compare it with Gini, it is more complex because it uses logs. Then we talk about decision trees. Decision trees, they are based on a tree model that splits data using Gini and entropy for easy interpretation. We have advantages or pros of decision trees. One being it is easy to interpret and visualize. It has no assumptions about distribution because of the non-parametric nature of the algorithm. Then it can capture nonlinear patterns. It requires fewer data preprocessing from the user, and it can also be used for feature engineering. Then we talk about the cons or advantages of decision trees. One is it is sensitive to noisy data. For example, let's say you have the data that has a lot of noise. When you use decision trees, it will not give you what you want. Then another one is the small variation in data can result in different decision trees. We also have it is biased with imbalanced data set. Another disadvantage is that greedy algorithms do not yield global optimum tree structure. Then last problem is as the branching goes deeper, you get exponential less data. So yeah, that's all about decision trees. Then we go to ensemble learning. Ensemble learning combines many weak models to create one strong model. The main goal of combining the weak models to create a strong model is to improve the prediction performance. And then we have basically two methods of ensemble learning, one being bagging, which trains models in parallel. Then we also have boosting, that trains models sequentially, where each model corrects the errors of the previous one. Then we talk about random forest. For random forest, it is a modified version of bagging that builds multiple decorrelated decision trees. Yeah, then we talk about the advantages or pros of random forest. One being, it works well with nonlinear data. Then it lowers the risks of overfitting. Then it runs efficiently on larger data set. And we also have its disadvantages. One of its disadvantages is it is biased while dealing with categorical variables. Then slow training can take, you can try very many times trying to get the model out of that data. It is not suitable for linear methods with a lot of sparse features. Then greedy algorithms do not yield the global optimum tree structure. Then we talk about SVM, which is support vector machines. Support vector machines, they basically find optimal hyperplane that maximizes margin between classes. SVM use kernel trick for nonlinear data. SVM, it is also powerful for high dimension data and is effective in text classification and image recognition. Yeah, that's it about support vector machines. Then we talk about principal component analysis, which is PCA. And the main goal of PCA is to reduce dimensions of data while keeping the information loss minimum. We have very many applications of PCA, and one of the applications is image compilation. For example, let's say the data you have is composed of images that are too big. You can use PCA to reduce those images to a size that you can fit in the model. Then we have pre-processing. We use PCA while pre-processing the data to remove the information that we do not want. Then data visualization, also have facial recognition. Yeah, but then We also have reasons why PCA should not be used. One of the reasons as to why we should not use it is it assumes that the variables are linearly correlated. So if the data doesn't have linearly correlated data, then the PCA is going to give us wrong predictions. Then it performs linear compilations, and it makes visualization easy to make but hard to interpret. Let's say you have the data set that has very many features. PCA will help you visualize those very many issues, but then when it comes to interpreting it, it is going to be hard. Then we talk about the real life application of machine learning. Talk about one of the problem. Now for my case, my problem is there is an increasing number of university students experiencing stomach ulcers and ulcer-related symptoms such as abdominal pain and indigestion. And why is it a problem? Ulcers cause persistent pain, reduce concentration in class, poor academic performance, because when the students, of course, are not feeling well, they will definitely dodge classes and end up performing poorly. Then it also lead to serious health complications. Then we see to whom is it a problem? Primarily university students. I'm basically concentrating on the university students, but also the campus health services are affected, and the university management at large, it is also affected since it manages the well-being of the students. Then we have, to what extent is it a problem? There is a noticeable increase in ulcer-related complaints and clinic visits, especially during examinations. When it is during examinations, students tend to read hard and even forget to eat, hence leading to ulcers. Then how is it a problem? Mainly is driven by academic stress, irregular eating habits, excessive caffeine intake, poor sleep because of overreading, and self-medication. Some people treat themselves when actually they are treating what they do not know. So we can use supervised machine learning models such as logistic regression and random forest, such that we can build a predictive system that identifies high-risk students early. So by doing so, at least before a student gets ulcers, the model can tell them earlier, such that they can take note. Thank you for listening.